So the last correct topic for 3.2, so we'll get this done and then we'll jump into the actual college algebra section 3.2, is factoring binomials, the prefix meaning bi meaning two, okay? So up until now, we've seen polynomials or trinomials where we've had 4 terms and we factor by grouping, or we have 3 terms and we use the AC method and factor, and every once in a while we've been lucky enough to get a binomial, but we've known how to factor it. Well, we just learned previously that you don't have to factor binomials. You can actually move it over and solve by taking the square root, but sometimes it might not just be a square, it might be a cube, and we want to know what to do with those, all right? So before we get to the rule, I make you work backwards, okay? So using the FOIL method, aka distributing, multiply the following pairs of binomials, and unless you remember the pattern, we'll see what happens, okay? These are called conjugates, where there's the exact same values, but the signs are opposite. So what's x times x? X squared. What's x times negative 5? Negative 5x, right? And then what's 5 times x? 5x. And what's 5 times a negative 5? Perfect, okay? And when we do this, the opposite signs, what happened to our middle terms? They'll cancel. And we're left with that difference of squares that I've been talking about for a little bit, okay? Notice this is going to be the same idea. So when we go to part example 2, we're going to do 3n times 3n, which will end up being what? 9n squared, perfect. And then 3n times a positive 7? Positive 21n, perfect. Negative 7 times 3n? Negative 21n. And then negative 7 times positive 7? It's okay. I'd rather you be safe than sorry. So negative 49 there. And again, what do you notice when we FOIL those guys? What happens to the 2 middle terms? They cancel and you're left with 9n squared minus 49. All right, last one. I mean, they're kind of just looking weirder and weirder. What happens when you take x cubed times x cubed? Remember, you add exponents, so that will become what? X to the 6, perfect. X cubed times a negative 4 will just be a negative 4x cubed. But then we'll turn around and do a positive 4 times an x cubed. That will leave us with a positive 4x cubed. And a positive 4 times a negative 4, which will leave us with a negative 16. What do you notice? The middle two terms cancel out, and you're left with x to the 6 minus 16. So in all of these, when we multiply by the conjugate, the middle terms with the x's or the x to the cubes or whatever canceled out. And then the front ended up being the square, right? X times x was x squared. And the back ended up being the square of the back number, 5 times 5, and the sign was always negative. So when you notice this pattern, it's called difference of squares. So notice this is a square, and it's a difference because it's subtraction. Even though there's a lot going on, 9's a perfect square, and n squared is a perfect square, so the square root of it is 3n, right? So that's a difference of 2 squares. And then x to the 6 we can break apart as x to the third, x to the third. So what it is in general is just, I call it open arms parentheses, okay? So whenever you see a difference of 2 squares, you just take the square root of the front number. So what's the square root of a squared? A. So he goes in front for both of these. Then you just take the square root of the back number. What's the square root of b squared? B. And then what do we need in order for those middle terms to cancel out? Opposite signs. Does it matter which one you do first? No, I typically do plus, minus. I do not know why. It can be minus, plus. It doesn't matter. So why I'm showing you this is because even though on that lesson we just did and we factored x squared minus 25 saying what are factors of negative 25 that add up to cancel each other out, and we use negative 5x and positive 5x, and we did the AC method, we don't have to do that. If you notice it's a difference of 2 squares, you can just do this open end arms parentheses, okay? What do I mean by that? This is a difference of 2 squares, so I'm just going to go like this. My open arms. What's the square root of the first term, x squared? What's the square root of x squared? X, so he goes in front. What's the square root of 9?
3.
Where's he going to go?
On the other side.
On the other side. And what do we need about the signs so the middle 2 terms cancel out? You got it. You just factored it.
It still seems hard though.
I think it's not as easy.
It's not, but like when you first look at it, it just seems like it's going to be.
Can I do it? Yeah. That's it. So that's what's kind of nice is like you've already just factored it. We don't have to do the AC method or anything. All right, so this is a square, n squared. 36 is a square, so let's do our open arms parentheses. What's the square root of n? squared. What's the square root of n squared? I just told you the answer. It's just n. Is everyone okay with that? What's the square root of 36? So he'll go back. And what do I need so the middle two terms cancel out? Positive and a negative.
Okay, this is not hard. Never mind.
You'll get the pattern down, right? Okay, so then we start kind of looking weird, and you're like, okay, 16 and 49, can I factor anything out of both of them? No. But what I notice about 16 is it's a perfect square, and what do I notice about 49? It's a perfect square, right? So I'm going to do my open arm parentheses a little bit bigger than normal because I have some bigger things going in there. What's the square root of 16? 4. And then what's the square root of x squared? X. So what's the square root of 16x squared? 4x, and he's going to go in front. And then we'll just do the same thing with the back. What's the square root of 49? 7. What's the square root of y squared? Y. So what's the square root of 49y squared? 7y. And what do we need so the middle two terms cancel out? You got it. So then you get to number 4, and you're like, well, I was on a roll, but now I'm stuck with 6. What's the square root of 6? It doesn't have a perfect square. But what we can't forget is the number 1 rule in factoring. What are we supposed to look for? GCF, right? And then I'm so bad, guys. I am worse than my students. I don't read instructions for the life of me. But if you go up here, it says factor the following binomials. Remember to look for a common factor first, right? Did anybody else read that?
No.
No, you're jumping right in with me, right? I'm guilty. All right, so what's something we can factor out of 6c squared and 6? A 6. So when we do that, what are you left with? C squared minus 1, right? So what's for sure part of our factoring? The 6, right? But then do you guys agree that what remains is just a difference of 2 squares? So I'm going to do my open arms parentheses right behind my 6, because I know my 6 is part of my answer, and I know I'm going to be able to jump to my final answer, right? What's the square root of c squared? C.
Oh, well, that's weird.
Yeah. What's the square root of 1? 1. What do I need for the middle terms to cancel out? Positive and a negative. You just cancel that.
Weird.
And what if you wanted to check it, you leave the 6 for last. You foil him and you get c squared minus 1. Then you distribute the 6 back in and you get your original. So remember factoring, you can check by re-multiplying them. Okay, so this is kind of the same thing. You get to 20, you get to 45, like then we have n cubed. Like nothing looks like a square, okay? But if you look at 20 and 45, what number can you pull out? A 5. And then what variable can you pull out? N. So we can actually factor out a 5n. When we do that, what's 20 divided by 5? 4. We took away its n, so nothing remains. And then what's 45 divided by 5? 9. And what's n cubed, take away 1n? N squared. So who's part of our answer? The 5n. And then, guys, this is the perfect square, and don't think you have to rearrange. So we're so used to that variable and being in front. That's not the rule. The variable doesn't have to be in front. It just needs to be a square in front and a square in back. So whoever's in front, his square root's going to go in front. Whoever's in back, his square root's going to go in back. So we're going to have this open arms parentheses, and we're not going to worry a thing about reordering it. We're just going to say, what's the square root of 4? So he's going to go in front. That's fine, okay? We're used to the constant being back, but this 4 is in front now. What's the square root of 9n squared? 3n. So he's going to go in back. And then what do we need for the middle term to cancel? Positive and a negative. You just factored it. And I think what blows my mind about these binomials is they start out so concise, but when we factor them, they look so much more elaborate. Like this little binomial got extended to this thing. It's kind of unreal. Okay, so this is the last one I want to kind of talk about. N to the 4th, any even power can be a perfect square. We'll just split them up evenly, okay? So open arms parentheses, how can we split n to the 4th up evenly into 2 places? N squared. All right, how do you split 16 up? 4 and 4. Is everyone okay with that? And then what do you need in order to have the middle two terms cancel out? But don't circle your answer too soon. Because sometimes when you have higher powers, there's another hidden difference of squares that comes out. Mind blown, right? What do you notice about that guy?
Could you make it n minus 2 3 times?
You can go again. Okay, so there's no such thing as a sum of 2 squares. So he's going to stay n squared plus 4. We cannot factor him. But do you guys agree that he is a difference of 2 squares? Right? So we can do little open arms for him as well. What's the square root of n squared? N. What's the square root of 4? 2. And what do we need for the middle term to cancel out?
And the negative.
Look at that.
Why can't we do it with the positive one?
Wait, where did the 6 squared plus 4 come from?
There's a 6 plus 4 somewhere?
Oh, never mind. I saw
It's an
that.
N.
Oh,
I'm
yeah.
sorry. Is it sloppy? Okay. So the reason why we can't do it with the plus, this is something I kind of get into detail with my other class, and I kind of just skipped over it with you guys, is the only reason why we can do this difference of squares is because it's a minus, because we need the opposite signs for the middle terms to cancel out. And what do we know about opposite signs when you multiply them? They are negative. So with the plus 4, what multiplies to be positive 4? 2 positive 2's or 2 negative 2's, but they wouldn't cancel each other out, right? So you'd have, like, you're like, oh, Molly, I think it's n plus 2, n plus 2. Well, if you FOIL that out, that'd be n squared plus 4n plus 4. So the only reason why we can do these is because the sign's negative, and so we can have opposite signs where the plus 2n and the minus 2n cancel each other out. Where here, the only way you can factor 4 is with 2 positives or 2 negatives, but they will never cancel each other out. So a sum of 2 squares doesn't exist.